We received a call on the assistance line from a very good local tech who had a few questions about diagnosing a no-start, no-crank concern. We had a few minutes, so we grabbed the video equipment and went over to lend a hand. When we arrived there was a 1996 Jeep Cherokee with a 4.0-liter engine with about 114,000 miles on it in the shop. The owner of the vehicle has already replaced the starter and ignition switch with no success, and then decided to have it towed. First step when diagnosing any problem is to get a basic understanding of how the system functions. Oh, a magic book of auto repair. Nice. There really is no magic book or magic box. It's all in gaining and understanding a system purpose and function. And in this case, a wiring diagram will provide us all the information we need to diagnose this problem. Now, the key component of this wiring diagram is the relay. Relays are a great place to start your diagnosis because they're usually easy to get to, and they're a great way to see how the voltage moves through the circuit. This circuit has a 4-pin relay. Here's a close-up view of the wiring inside of a typical 4-pin relay. Before we diagnose the no-crank problem, let's take a look at how a 4-pin relay functions. When you look at the bottom of a 4-pin relay, you'll see the pins are typically marked with the numbers 85, 86, 87, and 30. Pin 85 is the supply voltage and pin 86 is the ground for that voltage. When the current travels through the relay from pin 85 to pin 86, it passes through a winding of wire. This is the controlled side of the relay. Either the voltage supply or the ground side will be initiated by an outside control. Pin 30 is the high ampere supplied voltage, and pin 87 carries that voltage from the component such as the fuel pump, headlights, and in this case, the starter solenoid. When current passes from pin 85 through pin 86, a magnetic field is created which closes the switch between pins 30 and 87. When the switch closes between pins 30 and 87, high current can pass through the relay and initiate the component. Alright, a relay is a simple means of controlling a high current draw component with a low current switch. Okay, now that we have a better understanding of a 4-pin relay, let's take a look at how this starter system functions in relationship to the relay. When the ignition switch is turned to the start position, current flows through the switch to pin 85 of the relay. Now that looks like a great place to start testing. Let's go to the vehicle and do some checks. We are using a handy relay tester for this diagnosis, but if you don't have one, you can tap into the relay terminals with a jumper wire. While turning the ignition switch, we are getting 12 volts at the relay on pin 86. This proves the ignition switch is functioning properly. Let's go back to the wiring diagram for the next test. From pin 85, the current passes through the relay winding to pin 86. From pin 86, it travels through the neutral safety or neutral switch to ground. To test the ground circuit, we could go into the neutral safety switch wiring, or because the purpose of the switch is to go to ground, we can just run a jumper to pin 86 of the relay. When we jumped a ground to pin 86 and turned the ignition switch, the starter cranked and the engine started. Now we know for sure there is a problem with the ground circuit and the relay is functioning properly. To determine if the switch or the wiring was the issue, we connected the voltmeter to the positive post of the battery and the negative to pin 86. Remember, when the vehicle is in park and has a good ground through the neutral safety switch, the meter should be reading about 12 volts. Right now we have 0 volts, but when the shifter was jostled in park or neutral, as you can see, the voltage jumps between 0 and 12 volts. This tells us the problem is in the neutral safety switch. The neutral safety switch was replaced and the engine started. There's one last tip. When the garage called us, they were concerned because the tech was getting voltage on terminal 86 of the relay connector, but was also getting this voltage when the relay was removed. If we take a little closer look at the wiring diagram, the brown-yellow wire comes from the PCM Park neutral sense connection. The PCM sends a 12-volt signal through this wire, and reads the voltage drop on that signal. If it sees a 12-volt voltage drop, it assumes the vehicle is in gear. If it sees 0 volts, the neutral safety switch is grounding the signal, and it assumes the transmission's in park or neutral. Well, that's it for today. See you again next time in the Wells Garage.